Well, good evening, everyone, and welcome back here to the launch pad, or morning or afternoon, depending where you're joining us from. Welcome to our live launch coverage of DART, humanity's first ever double asteroid redirection test, launching out of Vandenberg in California here tonight. As always, as we get started, let us know in the chat where you're tuning in from. We'd love to welcome you here. If it's your first time here, welcome. My name's Zach. I'm the host here. Here at the launch pad, it's our mission to inform and inspire the explorers of tomorrow, and we believe space is better together. So we invite you to be active in the chat here tonight. Take a moment, join the Discord, and jump in the live comm section there if you want to hang out with the community, and subscribe so you never miss another live launch, docking, interview, or more. We've got a bunch more coming up this year, and we're excited to have you guys along the way here. But a very historic mission with NASA and SpaceX here today as they attempt the first ever test of what we would need to do should there ever be a Armageddon-style asteroid heading this way. And NASA has confirmed they called Bruce Willis. He refused to come out to the launch tonight. So no special guest appearances, but we'll be excited to hopefully have a clear launch out of Vandenberg here today. Liftoff currently scheduled for 10:21 p.m. Pacific, or about an hour from now. Both NASA and SpaceX will be going live with their coverage, and when they do, we will be patching that in here as well. But we're going to be answering your guys' comments and questions live throughout the night, so you can send those in anytime. Super easy. Just tag us at the launch pad, and that'll make sure our team is able to see those. And if you want to jump the queue and be the next question answered, you can send it in as a super chat or super sticker. We got people tuned in all over the world. We got Domo in Los Angeles, Michael's in Southeast Texas, got the Philippines, lots of Los Angeles, Texas. We got Abilene, Texas as well. Lots of Texas tonight in Los Angeles. We got Ohio. I'm up in Canada. It's great to have you all here with us this evening. As I said, if it's your first time here, take a moment and subscribe. It really does help us out. We're going to quickly run through what we're expecting to see for the mission here today and some of the stats. Then we'll patch into NASA, hear an update hopefully about the rocket, and go from there. But it's going to be launching, as I said, out of Vandenberg Space Force Base in California from Space Launch Complex 4, or SLC-4E. Going to be launching on a Falcon 9 Block 5 booster 1063-3, which has had a 182-day turnaround, so a long turnaround time, possibly because they wanted to make sure everything was perfect for this launch here tonight. The payload weighs 1,100 pounds or 684 kilograms, and DART will collide with Dimorphos at 6.6 kilometers a second. Its initial orbit will be heliocentric. So what they're actually going to be doing when they launch this is be targeting a larger asteroid that has some smaller asteroids in orbit around it. And they can't actually pinpoint those small asteroids, but we know they're there. So what they're doing is the DART will go towards the large asteroid, and very late into its mission, within that last day or so, it'll actually be able to use its onboard sensors to detect the smaller asteroid that they want to target and actually go and hit it. So very smart little device here. First stage is going to land on, of course, I Still Love You, 649 kilometers downrange, and the fairing halves will also be recovered by NRC Quest, about 750 kilometers downrange. This is the 129th Falcon 9 launch in its history, the 70th Falcon 9 flight with a proven booster, and the 95th landing attempt here tonight. So lots of things piling up there. It will be the 26th launch for SpaceX in 2021, which ties what they launched in 2020. So they're definitely picking up their speed here with a number more launches coming up this year with Starlink. And we have the 30th or so orbital launch attempt of 2021 also. So things definitely picking up. If you guys have a question, you can send those in the chat. We'll be answering those live throughout the evening. NASA's getting ready to go live here, so the moment they do, we will patch them in. We did want to take a quick moment and let you know, you might have seen it during the hold screen there, that we have released our holiday collection, and there is still time to be able to order that and have it arrive in time for the holidays. We also have a lot of other options on there if you're not wanting something for the holiday season, to get ready for the launch of James Webb or for the orbital launch attempt of Starship as well. So you can take a moment, check those out, and we appreciate your guys' support in that way. We've got Africa in the house. We got Leo and Phoenix. Great to have you here. Alpha Centauri. Sure. We got Adelaide, Australia, Tanzania, Wisconsin, Portland, South America, Peru. Hello, Australia, Chino Hills, Kevin. Yes, lots of people mentioning. Hopefully, we do not have any fog here this evening. That would definitely cause a little bit, but right now, from what we've been hearing, the weather is not too bad. So we'll see an update from NASA here shortly. A little bit about this mission. DART is a spacecraft that is an impactor and contains no scientific payload. So a very different launch than what we're used to. The spacecraft is a cylinder that is 12.5 meters tall or 2.4 meters wide. The DART has a mass of 670 kilograms, but only 500 kilograms will actually be there when it has impact. The satellite is equipped with a sun sensor, a star tracker, and an aperture camera, which it will use to navigate to Didymos B. The spacecraft will navigate to the asteroid autonomously, expecting to arrive in September of 2022, and we expect to bring you live coverage of when it has its approach. It'll use its ion thrusters that run on xenon, and that's when it'll make its approach to crash into the asteroid at 6.6 kilometers a second or 4.1 miles a second. This is expected to change the velocity by just 0.4 millimeters a second. Though a tiny change, this is expected to change the orbit of the object drastically. So we'll be able to hopefully see that appear. NASA does expect, if everything goes well, that orbital change will be able to be detected within about 10 to 15 minutes. So, though very minor, is something that they believe will be successful. DART is carrying a small sister spacecraft on board, a little CubeSat, that will have some cameras that 10 days before impact will separate and hold back and watch as DART approaches and makes its impact. And we'll be able to take photos of the impact itself as well as the debris caused by it. So a very interesting mission here, attempting to see what would happen if we ram things into the... sorry, I saw a super chat come in. It's making me laugh. Into the asteroid here. Justin, thank you so much for that super chat. Hello from the Philippines. Great to see you again. Oh my gosh. Richie starting the rug fund. Oh my goodness. If you were in our Discord earlier, we were talking about camera angle. I talked about camera angles, and I mentioned the floor, and they're now buying rugs. Heather, thank you so much for becoming a member. Welcome as VIP there. If you want to just DM me or Marcus on Discord, we'll make sure we can upgrade you there. Oh, Conan's jumping in on the rug fund as well. Thank you so much. Appreciate that. I guess we're going to have to pick a rug together over on the Discord. But great to have you all here. I know for all of our friends in the States, it's coming up on Thanksgiving, so happy Thanksgiving to all of you. We're glad to have you all here this evening. If you guys have questions, take a moment, send those into the chat, and we'll continue answering those as the evening goes along. But it's going to be a long mission, about 10 months, until we have actual impact. Very similar to what we saw with the asteroid collection earlier this year. I'm blanking on the name of the other asteroid, but we've done this before where we've gone, but we've never gone and hit it trying to move it. So it'll be very interesting to see how that progresses over this time. We don't have an exact date of impact yet, Michael, but we should have that once they get into orbit and begin their journey, then they'll be able to calculate that off more specifically. Catch it up here. Got an email from Starlink today, March 22, before you get it. A little bit longer of a wait there. Well, hopefully you get it a little bit sooner here. We're going to patch in NASA here, take a look at what updates they're giving us, and go from there. But stay with us for our live launch coverage of DART, humanity's first Double Asteroid Redirection Test.
Coverage of the Double Asteroid Redirection Test.
In a galaxy where asteroids have pummeled planets for billions of years, now one planet strikes back. For the first time in our planet's history, NASA will test an asteroid deflection technique. It's the first planetary defense method of its kind. NASA's Double Asteroid Redirection Test will intentionally ram itself into an asteroid and alter its orbit forever. At the crossroads of science fiction and reality, DART is part of our plan to defend planet Earth against potential future impacts. The test to protect the future of our planet begins now.
And in less than an hour, this SpaceX rocket will launch the DART spacecraft on a 6 million mile head-on collision course with a near-Earth asteroid. Welcome, and thank you for joining us here inside the NASA hangar at the Vandenberg Space Force Base on the central coast of California. I'm your host, Daryl Nail, and joining me is Kelly Fast. She is a program scientist with the Planetary Defense Coordination Office. Welcome, Kelly. It's great to have you here.
Thank you, Daryl. It's fabulous to be here helping to cheer DART off the planet.
Now, right at the top, let's talk about this. Are there any asteroids threatening Earth that we know of?
Now, thankfully, there are no known asteroid impact threats to Earth. You keep tracking them. We don't know of any. It's the one that we don't know about, that we're concerned about, but that's why NASA surveys for near-Earth asteroids, searches for them, and does a test like DART to have that in the toolbox.
Okay, and this asteroid DART is going to hit. What's the story there?
Well, the asteroid Didymos does not pose an impact threat to Earth. It keeps its distance, it gets no closer than 3.7 million miles to Earth's orbit. But that's what makes it a fabulous test situation for DART. We can go safely test an impact, the kinetic impact technique, and Didymos is the perfect laboratory for that.
Okay, and this spacecraft, is this something that could one day save the planet?
Well, what's nice about this, it's a nice mature technique, kinetic impact. You just impact something, but now we're actually going to test it. So this is going to be really good to have something in the toolbox that we've actually tried, taking it from modeling to an actual test.
Well, it is certainly exciting just to hear you talk about it. And when that moment happens in the fall of 2022, when that impact happens, that's going to be quite a moment.
It's going to be amazing.
All right, Kelly, thank you so much. And there's so much more to discuss about asteroids, planetary defense, and the DART mission. So let's get right into it with a quick breakdown of the DART spacecraft. DART has a mass of 670 kilograms, about a golf cart size or vending machine size machine. It uses hydrazine thrusters for propulsion and roll-out solar arrays for electric power. Now, DART has just one instrument on board, and there it is at the bottom. And that instrument is a Draco camera, which will feed images to an autonomous navigation system, steering it smack dab into an asteroid. Now, here's how DART got here. It was pulled by this semi-truck 2,900 miles across the country from the Applied Physics Lab in Maryland, all the way here to the Vandenberg Space Force Base. It took the team 46 hours to make the trip. You see that box right there? That's the protective container that was removed and is being stored here in the NASA hangar, while this DART spacecraft was carefully prepared for the launch and then put into that protective fairing. What a beautiful shot that is, Kelly. And then earlier this month, engineers mated the DART spacecraft inside its protective fairing to this SpaceX Falcon 9 rocket, which you see here, and DART's at the top of the rocket. It was then rolled out to the launch pad at Space Launch Complex 4 East, where it is now awaiting liftoff at 10:21 p.m. Pacific, 1:21 a.m. Eastern Time. Now, as we follow pre-launch operations, we also have some cool stuff to show you along the way. Our own Kelly Fast will give a fun demonstration. There she is. She's going to help us visualize a close approach asteroid, and she's moving quick. We'll also head into space where two astronauts will demonstrate in microgravity the kinetic impact technique that DART will be using. And also, this is kind of fun, we'll hear from a Hollywood director, Adam McKay, about his new science fiction comedy, Don't Look Up. It's about an Earth-ending comet that he'll compare with reality. But first, it's T-minus 45 minutes and counting. Let's get our first check on launch operations and introduce our launch commentators for today, NASA's Marie Lewis and Denton Gibson. Marie, preparations have been going on for many hours. Where do we stand right now?
Well, at the moment, Daryl, everything is still go for launch. We listened to polls just a few minutes ago internally with the spacecraft team and NASA engineering. No red flags, everything looking right on course. Want to introduce our commentator who's making his debut launch commentary tonight, Denton Gibson with the Launch Services Program. You're a mission manager, no stranger certainly to Falcon 9 and missions like this, but this is your first time in the commentary booth, so welcome.
Oh, thank you. Thank you. Thank you for having me. I'm excited to be here. It's launch day, so I'm looking forward to this.
And the teams on console have been going through their steps methodically since a little before 7 o'clock this evening Pacific time. There is a live view of the Falcon 9 rocket at Space Launch Complex 4E here at Vandenberg Space Force Base. And in less than a minute, we expect to hear the NASA launch manager, Omar Baez, poll the NASA team for launch readiness and readiness for propellant load to go ahead and proceed with that. If that is all go, that will begin at T-minus 35 minutes.
Right. And the reason why you hear this poll at this point in time, because there's so much going on much later in the process. So they try to have the poll early so that way the team can focus on the telemetry and focus on the data coming from the rocket and really pay attention to everything that's going on leading into those last few minutes.
And we're just standing by for that NASA launch manager poll.
This is the NLM on the NLM net with our propellant loading poll, starting with NASA CE.
NASA CE is go.
SMA.
SMA is go.
SMD.
SMD is go.
NASA mission manager.
NASA MIM is go.
LSP.
LSP is go.
Team's ready to proceed in the cryo tank.
So what you just heard was the NASA launch manager polling the various NASA teams to make sure that they're ready to go to proceed with propellant loading and launch. And launching a rocket is very difficult because it takes multiple teams to do that. And that's the various teams that you heard the NASA launch management poll in to make sure that they're ready to proceed with the count.
One thing I want to point out as we look at the rocket live on the pad on an unusually clear night here at Vandenberg is the soot on the side of the rocket. And that is because this booster has already been flown twice, in fact, but this is the first time for a Launch Services Program mission.
That's correct. We've done a lot of work getting to this point where we've comfortable where we are with this, and we're looking forward to this launch. And we have a lot of familiarity with this booster because we actually launched this for the first time on Sentinel-6 almost a year ago today.
Yeah, so happy anniversary, Sentinel-6, and we're getting ready to fly this booster once again on SpaceX's first interplanetary mission. So really exciting stuff coming up. By the way, weather is 90% go, so things are looking really great here so far. Daryl and Kelly, for now, we'll send it back to you.
All right, thank you, Marie and Denton. And so that's a great report. They're fueling up the rocket. Kelly, it's getting kind of exciting.
I'm really relieved to hear that report that it looks like things are going to go. And I think of the DART team. I mean, they've been working on this for years, but they've brought a spacecraft to the launch pad through a pandemic, and so they really need to be commended.
That's a great point, and you are right about that. Astronomers now all over the world, what's interesting to me about this is after this impact happens, they'll be able to see some kind of change?
Right, it's a unique mission in that there's an astronomical component to it. When DART impacts the moon of Dimorphos in fall of 2022, it will change the orbital period of that little moonlet. But from the Earth, it's just a point of light, but that point of light varies in brightness because that moonlet travels in front of and behind Didymos, and so that can be measured, and that rate of that light going up and down is what they're going to measure the change in that. And that's how we're going to see exactly what DART did to Dimorphos.
That's fascinating to me because it's literally just light you're looking at. We've never seen this little moonlet, but we see the light, and that's how we gauge it. More stuff to come from Kelly. Thank you very much. We are T-minus 41 minutes and counting. Here now is everything you need to know about the DART mission.
DART stands for the Double Asteroid Redirection Test, and the DART mission is to basically go hit an asteroid and see if we can move it. Earth is surrounded by small objects called near-Earth asteroids, and some of them are potentially hazardous. So planetary defense is cataloging, figuring out where all these objects are, but also trying to prevent them from hitting the Earth.
So far, we've only been able to predict the impact of 2 or 3 objects ahead of time. Those objects were small enough, they burned up in the atmosphere, and they were no danger to anyone. But what happens when an asteroid or any object is going to impact the Earth is that the Earth and that object want to be at the same place at the same time. We can't change the speed of the Earth, so the idea would be to change the speed of the impactor.
Now we chose to do this demonstration at a binary asteroid. The main asteroid is called Didymos, and its moon. DART is actually targeted to the moon of the Didymos system. And that's a much smaller target than any spacecraft has ever managed to hit before.
This is the first mission to fly the next sea. There's the ROSA, the solar arrays, have an Italian CubeSat, but it's really all about smart navigation.
The DART starts out with the traditional mission design concepts where we use star trackers and optical navigation. This will be the first time that the spacecraft will autonomously guide to a target.
The narrow-angle camera will be used by the spacecraft to home in on the target and hit it, and then the CubeSat will fly past the target and it will return the data directly to Earth on its own.
The tough part about it is that we're guiding ourselves into the asteroid, we're taking pictures, and we're sending data back all at the same time. You know, Didymos is a system that is tightly locked together, so we're going to try to push on the little moon and try to push it away in such a way that it will change the orbit of the asteroid and it will move it.
Mostly what we're looking to do is change the speed of the incoming object by maybe a centimeter per second. So that's not very fast, but if you do it enough seconds in advance, you can cause it to miss the Earth entirely.
DART is actually the first planetary defense mission. This is a continuing series of missions for planetary defense. We had this unique opportunity to demonstrate the method and also to learn exactly what happens when you crash a spacecraft at high speed into an asteroid.
While the launch and spacecraft team are busy preparing for liftoff, the mission operations team, located across the country in Laurel, Maryland, is preparing to communicate with the DART spacecraft after an hour-long flight on a Falcon 9. Let's bring in Samson Rainey now to find out what they're working on.
And if you guys are just joining us, welcome here to the launch pad and our live launch coverage of DART, the Double Asteroid Redirection Test. We want to leave that up as they were breaking down the mission there. We'll listen back in here as they talk to the team working on connecting with DART once it is deployed. But if it's your first time here, welcome. Make sure you hit that subscribe button. Saw a few questions come in, so we're going to answer those. We saw that why are they launching these at random times? Why don't they pick just a standard-ish time and stick to it? So that has to all do with their orbital mechanics and what target they are going for. Depending on what time they want to get to a specific object or a location, they have certain times that they can complete burns to leave Earth or get to higher orbits. Something like the space station, you can only launch to when the space station basically is overhead and he's trying to play either catch up or slow down so it catches up to you. They have to launch very specifically, otherwise they're going to be on opposite sides of the planet in orbits. For something like this, they probably had a little bit more flexibility on when they wanted to actually launch. They would have had a launch window when the asteroid was close to Earth, as it is in a different asteroid orbit than the Earth is. But they probably had a little bit of flexibility, but they normally want to launch at the beginning of a window. That way, if anything goes wrong with the booster or weather, they're able to have a delay and still have time and not have to wait days, months, or even years to have another launch attempt. If we think back to Lucy, that launched just a little while ago, Lucy only had, I believe it was an 11-day window or so before they would have had to wait years to be able to launch it again. So depending on what they're going to, that is why they have to be able to do so. Saw another question, are they recovering the booster? They will be recovering the booster on drone ship, Of Course I Still Love You, about 650 kilometers downrange. This is the booster's third flight here this evening. And we had a couple questions about what if they hit it and redirect it into a different orbit, which is what we want, but that orbit ultimately can cause something else's problems. Because they're targeting a little lit around a major asteroid, the orbit they're changing is the little asteroid's orbit around the bigger asteroid. They're not going to hit it with enough force for that asteroid to be ejected from the main asteroid, so it will stay in a stable orbit and never actually cause an issue. If they were hitting the main asteroid, that could cause that to wiggle, and then with different orbital gravities and planetary gravities, over time could ultimately cause an issue. but with this time, they've got a safe option for it. We're going to take a listen back in here for another update. T-minus 35 minutes and counting until liftoff of DART.
It was a beautiful day today on the central coast of California. And fortunately, we also have a beautiful launch weather forecast. So let's take a look at the satellite, and you can see the clear area as we shift from day into night. That's California in the center, of course, and that peninsula there, that's where we're launching the rocket. There are clouds to the north and to the west, but the area around the central part of the state where we are fairly clear with only some high cirrus clouds from a weak cold front that did move into the area and lower the temperatures here. Now, the Space Launch Delta 30 launch weather officer, Max Rush, says that this will bring elevated winds both on the ground and in the upper atmosphere. So they are watching those closely, but overall, take a look at this launch day forecast. It is nearly perfect, 90% go. The wind is 18 miles per hour. That is the gust out of the north-northwest. Temperature down to 48 degrees, so it's a little chilly out there. The concerns are winds and offshore clouds, as you saw some of that cloud cover over the Pacific. Now, the Space Launch Delta 30 weather team will be monitoring all of those winds and conditions as we move forward. Now, the winds on the ground and the winds up in the upper levels of the atmosphere, this is always being monitored by the Space Launch Delta 30 team. And to do that, meteorologists will use a weather balloon. And they invited us to watch and participate in that release that helps inform that launch weather forecast you just saw.
Hey, Mike Schmeiser, Daryl, meteorologist for the Space Launch Delta 30. Good to see you again.
Good to see you.
So what do you do here?
This is the Nerve Center for Weather Forecasting. There's about 240 sites just like this across the United States. And every day, twice a day, all of those sites release a balloon. So we're putting out the data for not only National Weather Service, but also for our forecasters. Absolutely critical data. Can't do weather forecasting without it.
Once you get the data, then how do you look at it and study it?
So the data comes in 5,000-foot blocks. Each one of these dotted lines shows 5,000 feet. As it comes in, it takes about 5 minutes for that data to come in. And this is the wind speed and direction.
So I understand you're going to be releasing a balloon in just a few minutes?
Yeah, absolutely. In fact, I've talked to the guys out there and they said you're good to go to be the guy to release it.
You're going to trust me with the weather balloon?
I trust colonels with weather balloons, so I'll trust you.
All right.
There you go, 10 seconds.
I feel like the biggest kid at a park.
5, 4, 3.
Perfect.
Interesting fact about that balloon that you just released, when it gets up to 100,000 feet, it'll be about the size of a Greyhound bus.
That's incredible. Yeah. Wow. Yeah. Well, Mike, thank you so much for having us out here. Really enjoyed it.
I'm really glad you came out. Thanks.
Took me back to being a kid and just releasing a balloon into the air. Thank you to the 30th for doing that. Now, most of the spacecraft NASA builds are intended to operate for many years or even decades, but not the DART spacecraft. It was built to be destroyed. So let's check in now with Raquel Villanueva, just about 5 miles away from us at a launch viewing location with more. And Raquel, looks like you got a little bit of a crowd behind you.
That's right, Daryl. There is a crowd of about a couple hundred people behind me getting ready and braving the chilly temperatures to watch this launch. And right next to me is DART Deputy Mechanical Engineer Lisa Wu to talk about how the spacecraft was built. Thank you so much for joining us today.
Of course. Thank you for having me.
So explain to us how DART was built and tested and designed.
That is a great question. So DART was built from the inside out. We started with components on the inside, including boxes such as our avionics that had the smart nav system or algorithm built by APL. Woo! That's basically what's going to autonomously take us to the asteroid. So once we tested everything on the inside, we closed up the box and we started doing everything on the outside. So we installed and integrated our solar arrays, our ROSAs, as you will roll out solar arrays. And then at that point, afterwards, we put on our Nexi engine, which you can see here in the video. That is our Nexi ion thruster, which is pretty cool. We closed up the spacecraft with blankets to keep the spacecraft nice and warm, and from there we had to take it through a series of very vigorous testing, including vibration testing and thermal vacuum chamber testing. All of this was really cool. One of our last things we installed was our Licha cube from our Italian friends, and then we put it in our shipping container and shipped it from Maryland all the way out here to California. Right now it is on our rocket and we are ready to launch.
And what was the biggest challenge the team faced when building the spacecraft?
You know, I think the biggest challenge that we faced was definitely having to build a spacecraft under the constraints of a pandemic. That was super difficult because building a spacecraft in itself is hard. But with pandemic and all the restrictions, it was really hard. But, you know, the team adapted. We did things very virtually. We did procedures online. We did shift work. And in the end, the awesome team we had made a spacecraft. So, hey, that's why we're here today.
Great. It's great to see you here now, and I'd just like to thank you for your time today, Lisa, and I will send it back to Daryl.
Kel and Lisa, thank you both so much. DART will take flight on a pre-flown SpaceX Falcon 9 rocket from Space Launch Complex 4 here at the Vandenberg Space Force Base. But once again, this pre-flown booster will make another return from space. For more on that, here's SpaceX engineer Jesse Anderson.
It was almost exactly a year ago when the Falcon 9 booster set to carry NASA's DART mission first took flight. On November 21st, 2020 at 9:17 a.m. Pacific time, Falcon 9 lifted off from Vandenberg Space Force Base here in California, carrying the Sentinel-6 Michael Frelich mission for NASA to its targeted orbit. Following that launch, the Falcon 9 booster returned to Earth for a land landing on the pad just adjacent to where it had lifted off from roughly 8 minutes earlier. This same booster recently flew a Starlink mission in May of this year from our Space Launch Complex 40 pad out in Cape Canaveral, Florida, landing back on our drone ship, Just Read the Instructions, in the Atlantic Ocean. Now today, this booster will make its third flight from the pad, where it all started with the launch of NASA's DART mission. Roughly 2.5 minutes after liftoff today, the Falcon 9 first and second stages will separate, and the second stage will ignite its single Merlin vacuum engine to carry the DART spacecraft to an interplanetary trajectory. The DART spacecraft will separate approximately 56 minutes into flight and spend the next 11 months cruising to its intended destination. Following stage separation, the first stage will make its way back to our autonomous spaceport drone ship called Of Course I Still Love You, which is currently stationed off the coast of California. Now keep in mind, it can be tricky to maintain the video feed as the booster makes its way back to Earth, but fingers crossed we'll get some great views as it completes its third trip to space. That's it from us here in Hawthorne. Now back to you in Vandenberg.
All right, thank you very much, Jesse. And now time to check back in with the launch team at the Mission Directors Center to see how the countdown is progressing. Maria and Denton, that booster looks very familiar. I was out here a year ago, and it looks great on the pad, though you can tell it's been to space.
Yeah, you sure can, and that's what we like to see. You know, the reuse is so exciting. And Denton, I know you talked about this already being a first for the launch services program, but you really were able to get a lot of insight from the reuse that you saw with cargo missions and the commercial crew missions for NASA. And so just building upon that, and it's really great to see. There's a live look again at the pad, and now we can see the liquid oxygen venting off the side of the Falcon 9 rocket. Fueling began about 9 minutes ago, and so the count has been really quiet these last few minutes, and that's a good thing.
Yeah, absolutely. I mean, that's what you want. You want an uneventful count. That means everything is going well. We're moving along in the count, progressing, and being where actually we're supposed to be at this point in time. So that's what we want to hear.
And liftoff is scheduled for 10:21 and 2 seconds p.m. Pacific time. So if you are watching from the East Coast, it's going to be already early the next morning. And there's a special reason why SpaceX fuels this close to liftoff.
Yeah, and that's because they use densified propellants, which are very, very cold. And so they fuel this close because they don't want it to warm up too much, and you want to keep it down in those really cold cryogenic temperatures prior to liftoff. And SpaceX has gotten very good at that, at fueling this late in the game. They're very efficient at it, and it's just a normal part of the process at this point.
All right, so we're going to continue to keep an ear on things. Next thing we'll be listening for is the SpaceX launch conductor poll at T-minus 4 minutes. That's the next milestone you see on that progress bar on the bottom of your screen. So we'll be listening in for that. And for now, we're going to toss it back over to Daryl and Kelly.
All right, thank you very much, Marie and Denton. And now we want to get back to the science of this mission and talk a little bit about the what if, Kelly. You know, this is a big deal. A lot of people probably haven't heard of this, like, oh, wait a second, should I be worried about asteroids now? But it really comes down to all the documenting and cataloging that you guys are doing. So how many asteroids are out there?
Right, well, NASA-funded telescopes are responsible for most of the near-Earth asteroid discoveries, which now number 27,532, according to the Center for Near-Earth Object Studies website.
Okay, well, and that's an up-to-date number.
It is.
So what about the asteroids that we don't know about?
Well, that's the thing of the subset that are of a larger size that could really do damage that the Earth's atmosphere doesn't protect us from. That larger population, we've probably only found about 40% of those.
Only 40%, which means there's a lot more out there.
So we keep searching.
Okay, well, we keep our eyes to the skies and eventually get a telescope up there, right, to look at this.
Right. NASA funds these ground-based telescopes that search for near-Earth asteroids, and they're doing a fabulous job, but it is also developing the Near-Earth Object Surveyor mission, which will be a space-based infrared telescope really designed to do this type of survey work and accelerate the rate of discoveries of near-Earth asteroids.
Great. Space-based telescope specifically purposed for looking for asteroids.
Right.
Looking forward to that mission. And so what if there wasn't enough time, though, to knock it off course? Well, earlier, NASA's Raquel Villanueva talked to two key people about how FEMA and NASA are working together on this.
While there's currently no threat of an asteroid or comet heading toward Earth, there is plenty of work being done to prepare for a potential threat. I'm here today with NASA Planetary Defense Officer Lindley Johnson and Leviticus Lewis with FEMA to talk about some of the measures being taken. Leviticus, Lindley, thank you for joining us today.
Glad to be here.
Yeah, you're welcome.
Now, how do your agencies work together when it comes to planetary defense?
Well, we at NASA are tasked with trying to find any impact threat that might be out there, any asteroid or comet that is close enough to Earth that it could impact us, and then be able to determine when and where that impact might occur so that we can inform the emergency response community if we don't have enough time to do something about it in space.
FEMA is the Federal Interagency Coordinator and also an all hazards organization. So planetary defense is just one more thing on our list of hazards that we should be prepared for.
One of the many emergencies. Now, Lindley, if there were to be an asteroid that posed a threat to Earth, what is being done to discover and track this?
Well, NASA and the Planetary Defense Coordination Office sponsors projects around the country at observatories and university space institutes that are searching the skies every night to find any asteroid or comet that could be an impact threat to the Earth in the future. We want to find them far enough in the future that we have a chance to do something about them, like use DART to deflect them off of that impact trajectory. But if the time is short and we're not able to do that, then an asteroid impact is just like any other natural disaster. And so the emergency response community needs to know when and where and what the effects could be.
And if an asteroid posed a significant threat, what steps would be taken next?
Well, we collect as much information as we can about the asteroid through the remote observing and determining the composition and size. It might be small enough that Earth's atmosphere would disintegrate it, but if not, then there could be damage at the surface. We want to be able to appraise the emergency response community how extensive those effects might be, what kind of area might be impacted by this natural disaster.
And Leviticus.
And if you're just joining us, welcome here to the launch pad and our live coverage of the launch of DART, the Double Asteroid Redirection Test. We are expecting liftoff In just under 20 minutes from now, SpaceX is preparing to go live with their feed, and the moment they do, we will patch that in for you as well and get an update from them on the state of the rocket as it counts down those final 20 minutes. If you guys have questions, send those into the chat. Tag us at the launch pad. We're going to continue answering in those chats, but listening into NASA and SpaceX for updates on the rocket as we progress towards that liftoff here of this very historic and unique mission that is taking place. But let's listen into a video here from the International Space Station.
Cool new NASA mission is called DART. Can you tell us and tell me a little bit more about what is NASA's DART mission?
Okay, yeah, so DART is NASA's first planetary defense test. So we're gonna try to do something we've never done before with the spacecraft. And now the purpose of this spacecraft and this mission, it has one purpose, and that's to crash itself into an asteroid and try to redirect it or try to move it into a different orbit.
So today, Shane, we're gonna demonstrate some of those principles that you laid out before. But can you tell us exactly how we're gonna do that?
We're going to try to demonstrate this asteroid kinetic deflection method, which is really the moment that spacecraft crashes into the asteroid. So here we go.
Shane is going to be the asteroid, and I'm going to be the NASA DART mission. I'm going to try to throw this CTB, and we'll look at the effect of that mass coming at him and the kinetic energy transfer. Shane will be perfectly stable. You ready? All right, here it comes. I've redirected Shane successfully. Pretty good. A while ago, we got out the door and we got some new solar arrays here on the space station.
And so the same technology we have here now on the space station is going to be used to power the DART mission on its way to this asteroid.
ROSA, in case you didn't know, but you knew, it stands for ISS Rollout Solar Arrays.
So we got a chance to go outside and install the very first two of these new IROSAs, or rollout solar arrays, on the very end of the space station, out on the port side.
November 23rd, and on your screen is a live view of Falcon 9 as it awaits its 10:21 p.m. Pacific Time launch from Space Launch Complex 4 East at Vandenberg Space Force Base. My name is Jesse Anderson. I'm a production and engineering manager on Falcon 9 here at SpaceX. Welcome to our webcast coverage for the Double Asteroid Redirection Test, or DART mission, managed by NASA's Launch Services Program. If you ever saw the movie Armageddon or played asteroids as a kid, this mission is for you. DART is SpaceX's first interplanetary launch for NASA and the first planetary defense test to see if humanity can change the motion of an asteroid in space or stop it altogether. As part of NASA's larger planetary defense strategy, the DART mission will prove that a spacecraft can autonomously navigate to a target asteroid and intentionally collide with it, a method of asteroid deflection known as kinetic impact. The target asteroid, which poses no threat to Earth, is the asteroid moonlet Dimorphos, which orbits a larger asteroid named Didymos. If all goes as planned, DART will direct itself to impact Dimorphos at roughly 15,000 miles per hour, or 4 miles per second, which is 6 kilometers per second, just under a year from now, somewhere between September 26th and October 1st of 2022. Scientists will use telescopic observations of the asteroids, images taken by an onboard camera, images of the DART impact event collected by an Italian space agency CubeSat, and data collected later by the European Space Agency's Hera mission to build a more accurate model and better prepare us to successfully defend the planet should a future asteroid impact threat ever be discovered. The DART mission is an awesome example of science fiction becoming reality, and the SpaceX team couldn't be more excited to be launching this payload to space. We will learn more about the DART mission later on in the broadcast, but first, let's take a closer look at the vehicle on your screen. Now, as many of you may know, on your screen is a live view of our Falcon 9 launch vehicle. Our two-stage liquid-fueled launch vehicle is in position at Space Launch Complex 4 East at Vandenberg Space Force Base. Today marks the 26th mission for SpaceX this year and 128th flight of a Falcon 9 vehicle overall. This is SpaceX's first flight-proven launch for NASA's Launch Services Program. This first-stage booster supported Sentinel-6A around the same time last November and took its second flight on a Starlink mission in May of this year. Now, if you're new to our webcast or unfamiliar with Falcon 9, what you see at the bottom 2/3 of the vehicle are SIP markings from its previous 2 flights. These markings are located on what we call the first stage, or the booster, and the first stage's primary role is to accelerate the vehicle all the way to the edge of space with the help of 9 Merlin engines. It will then drop off the second stage carrying today's payload, which is NASA's DART, or Double Asteroid Redirection Test spacecraft. Now, following separation from the second stage, the first stage will make its way back to Earth for the 3rd time, where we will then attempt to recover it on our autonomous drone ship, Of Course I Still Love You, and that is a live view of that drone ship right there on your screen. Now, if you turn your attention to the section above the first stage and the black carbon fiber inner stage, you'll see Falcon 9's second stage. About 2.5 minutes into flight, the first and second stage will separate, and the second stage will ignite its single Merlin vacuum engine to carry the DART spacecraft to an interplanetary trajectory, as I mentioned earlier in the webcast. Separation from the second stage will occur, and then the spacecraft will perform burns as it begins its journey in space. Now, finally, above this stage, placed at the very top of the vehicle, you'll see the nose cone structure, and that is called a fairing. Inside of that structure is the DART spacecraft. The 2 fairing halves are safely encapsulating the spacecraft to protect it from aerodynamic heating, loads, and contamination during ascent. The fairing halves we are using today are brand new, and we plan to recover them on our recovery ship, NRC Quest. Now, once the vehicle reaches the vacuum of space, we will jettison the fairing halves as the second stage continues on its journey to orbit.
Good evening from Hawthorne, California. I'm John Isbrecher, the Falcon Principal Integration Engineer. And the launch vehicle and spacecraft are in good health and ready for launch as we approach T-minus 13 minutes, 30 seconds to liftoff. The Falcon 9 team reported on console at T-minus 2 hours, 15 minutes. We received the final countdown briefing from the SpaceX launch director, and we began the final checks of the launch vehicle and the ground systems. Final checkout of the flight termination system was performed at T-minus 1 hour, 45 minutes. Now, most recently, we completed the poll to proceed with propellant load and launch. Propellant loading is ongoing. We started it on time at T-minus 35 minutes. Now, Falcon 9 is a bipropellant vehicle, meaning it uses 2 propellants, a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene known as RP1. Now, to burn the fuel, we need a source of oxygen, which we call the oxidizer. Most burning on Earth uses oxygen, which makes up about 21% of the air you breathe. However, in space, there is no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. Falcon 9's oxidizer is super chilled liquid oxygen called densified LOX. The liquid oxygen is chilled well below its boiling point to increase its density. And that allows us to load more into the first and second stage LOX tanks. Now, currently, fuel loading is complete on the second stage. We're continuing fuel loading on the first stage up until T-minus 6 minutes. Liquid oxygen is loading on the first and second stages right now. Now, in addition to its propellants, Falcon 9 also needs an ignition source to start burning the fuel and oxidizer. And for that, we use the chemical TTUB, which stands for triethyl aluminum and triethyl borane. We ignite the engines by first flowing some liquid oxygen and TTUB into the gas generator and the main combustion chambers. The TTUB burns in the presence of oxygen. So once we get that ignition, then we can introduce the RP1 kerosene fuel, and the Merlin engine goes to full power for liftoff. Now at liftoff, Falcon 9's 2 stages combine to hold over 1.1 million pounds propellant. And we'll burn through most of that over the 8.5 minutes it takes to land the first stage and get the second stage into its initial orbit. Now, once our Merlin engines begin to burn the RP1 kerosene fuel and the liquid oxygen, you're going to see the rocket essentially throwing the combustion exhaust out of the engine nozzles in one direction, resulting in a push on the rocket in the opposite direction. And this is the great example of Newton's third law of motion. For every action, there is an equal and opposite reaction. Now, we started the day with pretty good weather forecast, and the good news right now is weather officers giving us a 0% probability of violating launch weather requirements. The ground level winds are good, the upper altitude winds are good, and we don't expect to have any weather holds for launch. The weather conditions also look good for booster landing on our drone ship and for fairing recovery in the Pacific Ocean. So with that, the launch vehicle, the spacecraft, the weather, and the range are all good to go for a 10:21 p.m. Pacific time liftoff from Space Launch Complex 4 East.
Liftoff of Falcon 9 will kick off a roughly 11-month journey for the DART payload. The DART spacecraft will separate right around 56 minutes into flight, and from there it will spend the next 11 months cruising to its intended destination, intercepting the binary asteroid system between late September and early October of 2022. DART's target asteroid is the size of 2 football fields. Impact will occur when the distance between Earth and the asteroids is near its minimum, within 6.8 million miles or 11 million kilometers of Earth. This will enable scientists to observe and measure the change in momentum of the Dimorphos asteroid. And it's worth noting that Dimorphos is not a threat to Earth. Therefore, it's a perfect testing ground to see if intentionally crashing a spacecraft into an asteroid is an effective way to change its course should an Earth-threatening asteroid be discovered in the future.
Now, the DART demonstration has been carefully designed with 4 key objectives. The first objective is to demonstrate a kinetic impact with Dimorphos, the smaller of the 2 asteroids. DART will hit the asteroid nearly head-on, delivering enough energy to leave an impact crater, but not enough to destroy the asteroid, eject it from its orbit around that larger asteroid, or noticeably change the pair's orbit about the sun. Now, the second objective is to change the binary orbital period of Dimorphos. Now, the orbital period is the time it takes the smaller asteroid to circle the larger asteroid you can see here in the graphic. Currently, Dimorphos is in that original orbit. Scientists estimate the collision will shorten the smaller asteroid's orbital period by several minutes, placing it into that new blue orbit. Now, the third objective is to use ground-based telescope observations to measure the orbital period change before and after the impact. Telescopic observations in the weeks after impact will confirm that DART changed that orbital period of Dimorphos, and it'll reveal by how much. And then finally, the fourth objective is to measure the effects of the impact and the efficiency of that deflection. Now, choosing this binary asteroid target for the demonstration takes advantage of the fact that changes in that smaller asteroid's orbit around its larger partner can be more easily measured than the changes in a single asteroid's orbit around the sun.
To ensure the best possible data capture, the DART mission is taking along some pretty cool technologies to help capture this demonstration test. On board the spacecraft is the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, also known as DRACO. Now, this is not to be confused with the Draco thrusters on SpaceX's Dragon spacecraft. DART's DRACO will provide real-time streaming images of the asteroid as it approaches impact. In addition to the onboard camera, the team is also flying a CubeSat from the Italian space agency known as LICIA-CUBE, which stands for Light Italian CubeSat for Imaging of Asteroids. This cube will be deployed from the DART spacecraft 10 days prior to impact with the asteroid. LICIA-CUBE will use its onboard propulsion system to alter its trajectory, offsetting so that it flies past Dimorphos approximately 3 minutes after the DART impact to capture the effects of the impact. Now, it's pretty incredible to think about what a mission like this could mean for the future of planetary defense. Now let's take a closer look at what the NASA team is hoping to achieve with the Double Asteroid Redirection Test mission.
Little bit of time there. Stand by. 20
ago. Here we are, we can actually do something about it.
It's currently T-minus 4 minutes and counting. Everything continues to be go for launch. Spacecraft is transferred to internal power. On your screen, you can see the large structure next to Falcon 9. That's a strong back from Falcon East Coast launches, where we moved the strong back only 2 degrees, and then we retract it the rest of the way at liftoff. At Slick 4, once we get it back into position here in about another 40 seconds or so, we won't have to move it farther away at liftoff. Also, while we were watching the video, we have completed the fuel load on the first stage on time as expected, and we've begun chilling of the Merlin engines. Coming up on T-minus 3 minutes, everything continues to be go.
Stage 1 LOX load complete.
And we just heard that call out, LOX load complete. That is the first stage LOX loading being completed. Second stage will complete around T-minus 2 minutes. And Falcon 9 and DART teams continue to track no issues for launch. Weather is still looking great, as John mentioned. The range is ready to support, and SpaceX team is monitoring the completion of that second stage coming up next around T-minus 2 minutes. We should hear LOX loading completing for that stage. Now, as a reminder, we do have, if we do have a hold on today's launch for any reason, we do have a backup opportunity tomorrow with a liftoff time of 10:20 p.m. Pacific time, just a minute earlier than tonight.
Coming up on T-minus 2 minutes, waiting for the call out that LOX load is in closeout.
Stage 2 LOX load complete.
There we go. Stage 2 LOX load is complete. This completes loading of the over 1.1 million pounds propellants on the Falcon 9. All systems remain go for launch. Now the SpaceX ground computers are now draining propellant out of the lines that go up the strongback to the second stage, and that creates the white cloud that you see around the strongback. Pressure from the ultra-cold liquid oxygen line is being vented, and that causes moisture in the California night air to condense. Next event will be the startup call out at T-minus 1 minute. The first second stage computers on Falcon 9 will execute programs to prepare the rocket for flight, leading to ignition of the Merlin engines at T-minus 2 seconds and liftoff at T0.
And I want to quickly apologize there. Sorry about that, guys, but we got it back here in time. If you're just joining us, welcome. You're just in time for liftoff, T-minus 50 seconds and counting. Take a moment, hit that subscribe and like button for launch, this very historic asteroid redirection test here with the vehicle now in startup. As always in the chat, let's see it. Let's see a go, no go in the chat if we are ready for liftoff here, and let's listen in.
Go for T0. Let's listen into the terminal count and watch Falcon 9 transport NASA's DART spacecraft into orbit.
T-minus 15. 10, 9, 8.
We're throttled down. Avionics calls out good power on the vehicle.
Vehicle supersonic. Max Q.
We've gone supersonic. We're through the period of maximum dynamic pressure. And the Merlin 1D engines have throttled back up to full power. We're out of the throttle bucket. From here on, even though the velocity is rapidly increasing, The atmospheric density is decreasing, and so the loads are decreasing now on the Falcon 9. T plus 33 seconds.
4, 3, 2, 1, 0. Ignition. Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission. Vehicle is pitching downrange.
Stage 1 chamber pressure is nominal.
T plus 33 seconds. SpaceX launch engineers seeing a nominal conditions on Falcon 9 as we begin the trip to space carrying the DART spacecraft. M1D engines about to begin throttling down.
Power and telemetry nominal.
We're throttled down. Avionics calls out good power on the vehicle.
Vehicle is supersonic. Max Q.
We've gone supersonic. We're through the period of maximum dynamic pressure. And the Merlin 1D engines have throttled back up to full power. We're out of the throttle bucket. From here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and so the loads are decreasing now on the Falcon 9. Everything continues to look good with the stage 1 trajectory.
Invac chill has started.
Lead valve is open on the second stage engine. That's beginning the final chill prior to second stage engine ignition. Two minutes into flight, all continues to go well. In 30 seconds, we'll have 3 significant events coming up in quick succession. We'll get MECO, main engine cutoff, where we shut down the 9 Merlin engines. The stages will separate, and we'll get ignition of the MVAC-D second stage engine to power DART and the second stage into their parking orbit. We've throttled down to hold at 4 Gs, getting ready for MECO.
MECO.
Stage separation confirmed.
Invac ignition.
We've got successful stage separation. Second stage engine ignition now at full power on the Merlin engine. Next event coming up is going to be payload fairing jettison. On the left side, you can see the titanium grid fins on the first stage beginning to deploy as we get ready to bring the first stage back down to the drone ship, Of Course I Still Love You, in the Pacific Ocean. Getting ready now. There's
Fairing
the view
separation confirmed.
of the fairing. And we've got deployment of the payload fairing, and now the DART spacecraft exposed to the vacuum of outer space. Now, we will be attempting to retrieve these new fairing halves with the help of our recovery vessel, NRC Quest.
Stage 2 on nominal trajectory.
Everything going well with Falcon 9 and DART.
What you're looking at on your screen is a live view of that MVAC engine on our second stage, burning bright. We are currently in the first of 2 planned MVAC burns for spacecraft deployment today. At T plus 6 minutes and 40 seconds, you should see on your screen, hopefully we'll get some live views of the first stage entry burn. And that entry burn will last about 30 seconds. Now for the entry burn, we do relight the center E9 engine, and then partway through we relight the E1 and E5 engines, so that we have 3 total M1D engines helping to slow the vehicle down as it passes back into the Earth's atmosphere. Again, what you're looking at on your screen is the MVAC engine on the second stage. We're getting some awesome live views. And everything is still looking nominal for stage 2.
Flight guidance.
At T plus 5 minutes into this mission, we're just under 2 minutes away from the entry burn on the first stage, as second stage is continuing on its journey. Again, this is the first of 2 planned MVAC burns for this mission. Now, the Falcon 9 booster supporting today's mission will perform this entry burn for the 3rd time because it's previously supported a Starlink mission earlier this year and the...
Stage 2 on nominal trajectory.
Just to call out that stage 2 is looking nominal, which is great news. The first stage booster, again, supported a Starlink mission earlier this year and the Sentinel-6A mission in November of 2020. Now, both fairing halves for this mission are brand new and will be recovered for the first time on a recovery vessel, NRC Quest. And we are just about 30 seconds away from that entry burn on first stage. As a reminder, the Merlin engines on the first stage are optimized for sea level, and these do achieve 190,000 pounds of thrust during ascent and descent. And it looks like we got a live view on your left-hand screen of the first stage.
Stage 1 FTS is saved.
Stage 1 entry burn startup.
And we heard the call out as well as visual confirmation that the entry burn has begun on the first stage. Again, this is about a 30-second burn and just helps to slow the vehicle down as it's re-entering the denser part of the Earth's atmosphere.
Stage 1 entry burn shutdown.
And as you could see, the engine shut down on your screen. We did hear a call out that entry burn is complete.
Stage 2 FTS is saved.
Stage 2 continues on a nominal trajectory. Now coming up in just a little over a minute will be SECO 1. That is second stage engine cutoff 1. Again, there's 2 burns for the MVAC engine on the second stage, so we are in the first burn.
Expected loss of signal, Cook.
So we should see this engine shut off here shortly. And about 20 seconds later, we'll see or hear the landing burn call out on first stage begin.
MVAC shutdown.
And we just
nominal
had...
orbit insertion.
That's what we were waiting for.
Stage 1 landing burn startup.
So we got SECO 1 on second stage. We got a confirmation of good orbit, and the landing burn has begun on first stage. And now we have a live view of first stage making its way to, of course, I Still Love You.
Stage 1 landing leg deploy.
And we had some incredible views. Now we're just waiting for some confirmation of that first stage landing here in a second. As we have a live view of second stage currently with the engine cut off as it's coasting towards its targeted orbit. And we will wait for that confirmation of that first stage landing, but you have just witnessed Falcon 9's 26th flight for this year. And we will confirm once we have that confirmation for that first stage landing. So now at this time, our mission isn't over just yet. The second stage is now embarking on its first coast phase. Coasting in this orbit will last about 20 minutes, and we will light that MVAC engine for a second time shortly after T plus 28 minutes and 38 seconds. So we'll see you back here at T plus 28 minutes. Welcome. Back to the webcast of his 88th overall successful recovery of a first stage. The second stage completed its first burn, placing the Falcon 9 and the DART spacecraft in the desired orbit. And right now we are approaching the second engine burn, the burn of the second engine to carry Falcon 9.
Invac ignition.
And there's that SES-2, as you can see live on your screen, lighting up there. Now this burn is planned to last a little less than 1 minute. And during that time, we will add about 3.5 kilometers per second to our velocity. Now you can see the gauge on the screen showing stage 2 quickly gaining speed. We'll add about 3.5 kilometers per second, or about 12,500 kilometers per hour to our velocity. Again, this burn is the second burn for this mission. And cutoff should be coming up here shortly.
Invac shutdown.
We heard that call out that NVAC has shut down. Now just waiting for confirmation of good orbit.
Nominal escape burn.
And there is that confirmation of a nominal escape burn.
Jesse called out nominal escape burn. What that means, the Falcon 9 second stage, with DART still attached, has escaped Earth's velocity. It's now in what's called a heliocentric orbit. It's circling the sun in an orbit that takes it from just inside the Earth's orbit to just outside, where in 10 months, the DART spacecraft and those 2 asteroids should arrive at the same time. Now, the DART spacecraft is still attached to Falcon 9's second stage, so we've got one more major activity remaining in the launch mission, and that is spacecraft deployment. It's timed to occur at about T plus 55 minutes and 42 seconds. So we're going to take another short break, and we'll see you back here at T plus 55 minutes for the DART spacecraft deployment.
Acquisition of signal, goodbye.
Welcome back to our launch coverage of the DART mission for NASA. If you're just joining us, we had an on-time launch at 10:21 p.m. Pacific time, followed by successful ascent stage separation. First stage landing took a little bit, but we got the pictures. And it's 2 second stage engine burns that have put DART on an escape trajectory from Earth. There's one more major milestone coming up to complete today's mission, and that is deployment of the DART spacecraft from the Falcon 9 second stage, due to happen in about 10 seconds from now. The view you see from the second stage camera is the DART spacecraft. We're going to listen to hear the call out and watch for DART separation.
DART separation confirmed.
And to those watching, you're witnessing a successful deployment of the DART spacecraft. The impact of the DART spacecraft with the small asteroid Dimorphos is scheduled to happen sometime between the end of September and early October in 2022, when the double asteroids are closest to the Earth. Now, during impact, the spacecraft will be traveling roughly 15,000 miles per hour or 4 miles per second. This is going to be an exciting collision to witness, and we wish everyone at NASA the best of luck with the rest of the mission.
Those are some incredible views there. Now, one quick clarification. This is actually the 95th recovery of a Falcon first stage, which is the 88th for a Falcon 9. And with successful payload deploy, that brings our webcast to a close. For continuing coverage of the NASA mission, head on over to nasa.gov/live or check them out on their social channels. Thank you to NASA for entrusting us with the DART mission, as well as the range for their support. And of course, thank you to all of our viewers. We hope that you enjoyed the webcast this evening, and we'll see you again soon.
And thanks again, everyone, for hanging out with us tonight for our live coverage of the launch of DART. Again, apologies for some of those tech issues, but we're glad to see DART off into the races. Glad to have you all here. We're going to be live in less than 5 hours for the launch of Russia's new module to the ISS, and we hope you will join us then. The link there is in the chat. If you haven't yet, take a moment to engage that like and subscribe button, and if you want to hang out, continue the conversation, head on over to our Discord. We're over in live comms, and be glad to see you in there. But for now, this is Zach with the Launchpad, signing off. We'll see you next time.
Well, tell me a little bit.
It's really to complete the investigation, to understand what has happened during the and after the DART impacts, to understand the dynamics, the geology, what the asteroid is made of. And the name is quite funny. Actually, we had an evening with the scientists, and we were thinking about names, and I only had a constraint from my boss saying we don't want acronyms for once. So the idea...
yeah, and so it was a perfect choice, but it's because there are two aspects of this, right? What is this?
Exactly. So these are the CubeSats. So Hera will bring with it two CubeSats, one called Milani, after actually the scientists who brought up the name of the mission and the concept, and Juventus. So the two CubeSats will perform scientific investigations. Here we're seeing the booms deploying from Juventus. That's actually a low-frequency radar. What it does is actually like a X-ray. We'll want to understand what is the internal structure of the asteroid, understand if there are voids or if it's a monolithic rock.
How about that?
Yeah, so imagine...
Literally going into the crater that DART created?
Exactly, that's the purpose. And so Hera comes after the goddess, the Greek goddess of marriage. And the idea being that despite being hit by DART, the two asteroids will stay together. So that was kind of the history behind the name.
I love it.
Well, yeah, and we just got DART off the planet. And so why is it important now to, a few years later for Hera to go and then follow up?
Yeah, absolutely. So we are so excited about DART. It was an awesome launch. And we're all expecting beautiful science data to come next year. But then the purpose of Hera is really to complete the experiment, to get close and personal, and get all of the science data that we need to actually calibrate our numerical impact codes, meaning that we can reproduce on our computer simulations exactly what happened during the DART impact. And that will allow us in the future to be able to design a planetary defense mission if we need to on another object. So we will have all of the models calibrated so that we can use it on another asteroid.
All right, Ian Corneli, fascinating stuff and a great mission to follow up on this DART mission. Appreciate you being here.
Thank you for inviting me.
All right. Well, now we are getting to the big moment where we're going to try to acquire a signal from the DART spacecraft. And so let's take a look inside at the Mission Operations Center and the Johns Hopkins University's Applied Physics Laboratory. If we have that, that's where the real work is going to start being done in terms of acquiring that signal. And in just a few minutes, we're expecting that DART team to do just that, acquire the signal. But as Marie and Denton mentioned, it's not an exact science. We got to go through some stations to make sure we acquire that signal and get it in there. But you're pretty familiar, Kelly, with the people who are going to be in that room waiting for the signal to come in.
Well, the Planetary Defense Coordination Office and the Planetary Science Division have been working with the Applied Physics Lab and with the co-investigators at other institutions for a long time on this. And yes, it's a mission, it's a task. People have their jobs that they need to do, but I mean, these are individuals who are really passionate about what they're doing, and so they're really taking this to heart. And I'm sure they're still on pins and needles as they work their way through this part of the mission.
Speaking of pins and needles, there we see the room there, as you can see at the lower bottom of your screen, awaiting DART acquisition of signal, and that area right there is called the command pit at APL, and so those folks are patiently and intently listening for communication from DART to the ground. So while we await that, let's send it over to Marie and Denton, who are monitoring the launch team communications as we await acquisition of signal.
So right now, Daryl and Kelly, it's just a lot of waiting and listening. There's almost no chatter going on the loops. Everyone is just kind of waiting with bated breath. At this point, we're at T plus 1 hour, 4 minutes and counting. And just in these it all kind of comes down to these final minutes. When are we going to get that signal? Yeah. Years of work. Some of the people in this room, probably, if not all of them, have poured years of their life. This is their life's work into this mission. And so what's it like waiting for this confirmation?
Yeah, and so, having been on the launch vehicle side and sitting on console and working this, what you've been working years to kind of get to this point. And as you mentioned, the spacecraft team has been dedicate most of their careers or their life's work to the spacecraft. So, getting through the launch, he's like, great, we had a great launch, everything went successful, but you want to make sure you get that confirmation from the spacecraft. So it's a little, excitement that we got through the launch, but it's a little nervousness as we wait and say, okay, we want to make sure the spacecraft is doing okay. And so it's a mixture of excitement and nervousness at the same time.
Yeah, and you mentioned nervousness, and we see some clapping. We haven't heard anything, so trying to see if we can find out if.
So we waiting to get positive confirmation that we've actually have got signal from the DART spacecraft. So we're just waiting to get word.
If you're just joining us, this is a live view of the Mission Operations Center at Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. This is where the spacecraft team is waiting to receive confirmation of acquisition of signal from the DART spacecraft, currently on its way to the Didymos asteroid system, where we expect it will impact the moonlit Dimorphos in late September of next year. And Denton, while we wait to hear whether we have acquisition of signal, I was going to mention, the teams rehearse this many, many times. There are pages and pages of procedures that have to be followed down to the letter, and you go through everything a final time during the mission dress rehearsal. This team did that less than a week ago from the control rooms here in Vandenberg, at Johns Hopkins, all around the country. And this is the one thing that you can't really predict. You don't really know when it's going to happen.
Right. So it all comes down to different the environments and different variables that play out on launch day. And whether you're going to get that signal early or whether you're going to get it later, you won't know until you get up there. So, rehearsals and practice is great for dealing with anomalies and things along those lines, but at the end of the day, you're 100% sure of when it'll actually happen until launch day.
And so at this point, we are officially inside that window when we think we could get acquisition of signal. So it could happen at any moment.
Right. And you can look in the room and you can kind of see that nervous energy of people just waiting to get that confirmation of spacecraft, I would say first signal from the spacecraft, and make sure that the spacecraft is doing well.
And then after that signal is acquired, there's even more to be done then. That's a huge moment of celebration, sigh of relief, but there's still a lot of work to be done on the other side of that.
Absolutely. So that's when the DART team, the spacecraft team, that's when their work really begins. The launch vehicle team pretty much did all their work kind of leading up to spacecraft separation. Now it's time for the DART team to kind of really moving forward on the operational side of their mission. At this point, because they spent years developing the technology, building the spacecraft, and now, since we've had a successful launch, the operational side of their mission really begins. Mm-hmm. So we just got confirmation that we do have acquisition of signal, which is great news that the spacecraft is being able to talk to the team on the ground. So that's a good thing.
Yeah, huge news. It's a process from this point. The solar arrays on DART will still have to unfurl. That process does not begin until about T plus 1 hour and 42 minutes. So that's still quite a ways away. And that process, once the first one begins to unfurl, that happens very gradually, and then it's almost an hour before the second one is fully unfurled, and the span of those stretches fully out into space, each one reaching almost 30 feet in either direction, and they are... Okay, and just to finish that thought, they are 3 times more powerful than standard solar arrays. We've just heard that NASA launch manager Tim Dunn is standing by with Daryl and Kelly to speak to them about the success so far in the DART mission, now that we have confirmation of acquisition of signal. So Daryl and Kelly, Denton and I will sign off from here, and we will send it back to you.
All right, thank you, Maria and Denton. Great job out there, and congratulations is in order for Launch Services Program. Tim Dunn joining us here on set. Just popped in, fresh from the control room.
Yes.
How'd it go from your perspective?
Oh, it went great. Just terrific. We got it all settled in about 3.5 hours before T0. And we had a couple of minor issues with a little bit with the pad, few items with the rocket, but it's amazing, Daryl, to watch the integration of the NASA team and the SpaceX team work through anomalies and issues to make sure that we are tracking to that precious 1 second instantaneous window that we had to hit. Obviously, we had perfect weather today, so that was not a player at all. No range instrumentation issues at all. So it was just a terrific countdown, and any countdown that ends in a successful launch followed by spacecraft separation is a great day.